section we're doing today is section 1-1.3, and we begin talking about quadratic equations. The definition of a quadratic equation is that it is an equation that has the form of ax squared plus bx plus c equals 0. A, b, and c have to be real numbers, and a cannot be 0. The reason a can't be 0 is because if a is 0, then this whole term right here would get canceled out, and then all that would be left is the bx plus c, and that would be linear. So that would mean it's still an equation, it's just not quadratic. B and c can be 0, so that's not an issue. The only one that can't be 0 is that leading coefficient a. A very useful property for us when we are dealing with quadratic equations, or really any polynomials, is what is called the zero product property. And this is something you guys have used for years, whether you realize it or not. If you have two values, a and b, that are multiplied together and the answer is 0, we know that's only true if one of them is 0. I mean, to think about that, if I tell you that 5 times something equals 0, you guys automatically know that the something that you're multiplying that 5 by has to be a 0. So the options there are either a is 0 or b is 0. And so we know that a times b equals 0 if and only if a is 0 or b is 0. We want to solve this by factoring, and we're going to use that zero product property. So the first thing we're going to do is make sure that the equation equals 0. So we have to move this -4 back over to the other side. We're going to add 4 to both sides. So we will get x squared minus 5x plus 4 equals 0. And then we want to factor it. Just like we practiced factoring in the last chapter. We put our two parentheses here because notice there's no number here other than a 1. So x will go here, x will go here. Remember that this sign right here is the first thing we look at. And that tells us that these signs inside the parentheses will be the same. Then we look at this one, and that tells us since they have to add together to be -5, they're both going to be negative. So right away we know we've got x minus and x minus. So we write down the factors of 4 that are both negative. -1 and -4, or -2 and -2. And the ones that work there are the -1 and the -4. So what we do then is now we use the zero product property. This statement is only true. One way it could be true is if x minus 1 equals 0. The other way it could be true is if x minus 4 equals 0. And then we just solve these two little equations. We add 1 to this first one. We get x equals 1. We add 4 to the second one. And we get x equals 4. So we have two solutions, two numbers for x that will make this equation true, and one of them is 1 and one of them is 4. If we want to check this, we can always take this value 1 or this value 4 and plug it back in up here into the equation anywhere you see an x, and it will make that statement true. We're not going to take the time to check it right now, but that's pretty easy to do with a calculator. Now, the process of completing the square is a process that's a little bit more difficult than factoring, so we don't like to use it as much. But here's the process for completing the square. The first thing we have to do is move the constant, to the other side. So we're going to get rid of this 3 by subtracting 3 from both sides. So now we have 2x squared minus 10x equals -3. The next step is we need this x squared to just have a 1 in front of it. So the way we deal with that is to get rid of this 2, since it's 2 times x squared, we're going to just divide everything by a 2. And we have to divide everything by 2. So that gives us x squared minus 5x equals -3/2. The next step here, and you're going to probably have to watch this a couple times so you can kind of get these steps, because the first step, and I'll number them here. This is step 1, step 2. So our third step here is we need to figure out what goes in this gap here. You may have noticed that I put a gap in there, and we have to figure out what goes in the gap, and this is the part that really completes the square. So the way we find out what goes in the gap is we take the b value, which is -5, and we divide it by 2. So what goes in here is -5/2, and that value is always squared. But since we added -5/2 squared to the left-hand side of the equation, we also have to add -5/2 squared to the right-hand side of the equation. You can't just add to one side, you have to add to both. The nice thing about this now is this has now formed a perfect square. So our fourth step is to rewrite this in its perfect square form. And the perfect square form is x, and we get that x from right here. And then this goes in here, so -5/2. It may seem like we're just ignoring that -5x, but that's not the case. If you actually took this x minus 5 squared and multiplied it out, FOILed it out, you would get back to what you have right here. So we're not ignoring it. Again, I don't want to take the time to do that. The video will be long enough, I'm sure, the way it is. So we're not going to take the time to do that right now. But if you multiply that back out and FOIL it, you'll get back to step 3. Right here, we need a common denominator. Notice this is -3/2 plus 25/4. Our common denominator then would be 4. So notice this would be -6/4. So when we add -6/4 plus 25/4, we get 19/4. Now we only have one x in the problem, and we can simply solve by getting the x by itself. So the first thing we do is to solve this now. We're done completing the square, now we're just going to solve it. We take the square root of both sides. So now we've got just x minus 5/2 equals, I'm going to break this up. You've got the square root of 19 on the top, and the square root of 4 on the bottom is 2. And remember, when we take the square root of both sides of an equation, we have to put in the plus or minus. So we've got the plus or minus there. Then our last step to get the x by itself is we add 5/2 to both sides. And so that gives us our answer of x equals 5/2 plus or minus the square root of 19/2. And those are two solutions, 5/2 plus square root of 19/2 and 5/2 minus square root of 19/2. And again, I understand that process is probably new. You are probably going to have to watch this example maybe a couple times and go through those steps. What did we do? Okay, get rid of the constant, get the x squared by itself, complete the square, and then solve it. The nice thing is we don't have to use completing the square very often to solve things unless we're specifically asked, because, and I'm not going to take time to do it on the video, but this quadratic formula is really the standard form of a quadratic equation. They applied the completing the square process and they came up with this quadratic formula. And remember that what we're looking at here is the equation ax squared plus bx plus c equals 0. So that's where the a, b, and c values in this equation are going to come from in this formula. So we want to find the real solutions of this formula, of this equation, using the quadratic formula. So if you didn't write it down, you may want to go back and write that down. But our quadratic formula says this: x equals negative, notice this is a, b, and c, so negative 3 plus or minus the square root of -3 squared minus 4 times a times c over 2 times a. So the first step is just, plug everything in. Now we just have to simplify what's there. So now we've got 3 plus or minus the square root of 9 plus, because you've got a negative here and a negative here. That's going to give you a plus. So 4 times 4 times 2 is 32. over 8. And that gives us 3 plus or minus square root of 41 over 8. So we want to try and simplify that radical, square root of 41 if we can. And when we look at that, no perfect squares go into 41, so that is our answer, 3 plus or minus square root of 41 over 8. Doing another example of that, same thing. Here's A. B in this case is 1, because there's automatically a 1 in front of that, and C is 5. So x equals the opposite of B, plus or minus. We've got B squared minus 4 times A times C over 2 times A. And that formula is something you are going to want to memorize because that's something that we'll use quite a bit. So negative 1 plus or minus square root of 1 minus 60 over 6. So that gives us negative 1 plus or minus square root of negative 59 over 6. Now you may remember this negative here means that that answer is imaginary because we can't, with the real numbers, we can't take the square root of negative 59. So the way we write that is negative 1, and when it's imaginary we split it up. So negative 1 over 6 plus or minus the square root of 59 over 6, and then we put that I on there to show that that portion right there, that second part, is an imaginary number. So we can get real answers from the quadratic formula. We can also get imaginary answers from the quadratic formula. And if you look at this, this is the discriminant. And the discriminant is the b squared minus 4ac. Notice that this part right here is the stuff that's inside the radical for the quadratic formula. This is the value that determines the type of solutions that we have in a quadratic equation. Notice the first example we did, there was a positive number in there, so we got 2 real answers. The second example we did, there was a negative number in there, negative 59, so we got 2 imaginary answers. And here's our descriptions for the discriminant. If that discriminant is positive, greater than 0, the equation has 2 distinct or 2 different real solutions. If d equals 0, so in other words, if the stuff inside that radical just cancels out to a 0, notice then in your equation you're going to have plus or minus 0, then the equation has 1 real solution, and that solution is what we call a double root, because it's actually the same answer happening twice. In that case, you would have been able to factor what was there. If d is less than 0, or if it's negative, then the equation has no real solutions. It has 2 imaginary solutions. Okay, and that's the example we just had, or that's the situation we just had in this last example. So let's find the number of real solutions using the discriminant in these 3 examples. We just used the discriminant, which is the b squared minus 4ac. So in this problem, d equals 4 squared minus 4 times 1 times negative 1. And so we have 16 plus 4 is 20. Since 20 is positive, that means we have 2 real solutions. Okay, because inside that radical we're going to get a 20. That's a positive number. For b squared, so negative 2 squared minus 4 times a times c. Notice here we get 4 minus 4 times 4 is 16, so 16 over 3. And getting a common denominator, this would be 12 over 3 minus 16 over 3, and that's negative 4 over 3. So that tells us there's no real solutions. There are 2 imaginary solutions. Okay, so again, positive means 2 real solutions. A negative discriminant means 2 imaginary solutions. As we look at C, we've got, again, D equals B squared, so negative 12 squared, minus 4 times A times C. That's 144 minus 144. And that gives us 0. And so in that example, when it equals 0, that tells us there is one real solution. Oh, wow. Solution. There we go. That's kind of right. And again, remember that's a double root there for that last one for part C. We need to remember that the whole purpose of math most of the time is to use it in situations, and quadratic equations can be used to model real-life situations. So for example, let's say we've got a rectangular building lot that is 6 feet longer than it is wide. So we want to draw a picture. It's a rectangle. I said 6 feet, I think. It's 8 feet longer than it is wide. So let's just say that this is the width, x, or some variable. That means this side is 8 feet longer, so x plus 8. And it has an area of 2,900 feet squared. Find the dimensions. So how do we find area? Well, area of a rectangle is length times width. So for us, that is going to be x times x plus 8. But we know the area is 2,900. So if we distribute this, we get x squared plus 8x. So notice this is a quadratic equation. X squared, if I bring everything over to one side, I'm going to have 0 equals x squared plus 8x minus 2,900. That would be just subtracting this from both sides. So let's try and solve this. It looks like something we might be able to factor, although the number is pretty big. But let's go ahead and take a shot at it anyway. Get x and x. Again, this tells us the signs will be different. So one's positive, one's negative. This one tells us the bigger one is positive. So factors of 2,900. Well, just to start with something easy, we've got 29 and 100. 29 would be negative. If we go up a little higher than that, we would have 58 and 50. Notice I doubled this one, and I cut that one in half, and actually that one ends up being the one that we need, except, sorry, 58 is positive, and negative, we got a negative 50. So notice they add together to be 8, and that's what we need. So plus 58 minus 50. Remember the zero product property, x plus 58 equals 0, x minus 50 equals 0. So in this case, we subtract 58, we get negative 58. In this case, we add 50 and we get 50. Now we have to think about this. This is a real life situation. It's not possible for our dimensions to be negative. Okay, you don't say that something's negative 58 feet long. So we find out that this side is 50 feet, then this side is 50 plus 8, so this side would be 58 feet. So those are the dimensions of this lot. A jet flew from New York to Los Angeles, a trip of 4,200 miles, 200 kilometers, sorry. The speed for the return trip was 100 kilometers faster than the outbound speed. If the total trip took 13 hours, what was the jet speed from New York to Los Angeles? Okay, so we've got a situation here. We've got New York, we've got LA, and they're traveling here and then back. This is the distance formula. If you remember the distance formula, distance equals rate times time. So we know the distance is 4,200 kilometers. That was given to us. And what we don't know is the rate or the time on the way out. So for the first equation, we've got 4,200 equals rate times time. And I'm going to use, what should I use here? Subscript L, since we're going to Los Angeles. On the way back, the distance is still 4,200, but notice what happens to the rate. The rate increases by 100 kilometers per hour. So now we know that the rate coming back is the original rate plus 100. We don't know about the time, so I'll just call that time back to New York. Okay, but they do tell us something about the time. They tell us the total trip took 13 hours, which means the time going to Los Angeles and the time coming back to New York equals 13. So we can do a substitution here. Let's go ahead and substitute in for this one. So let's solve for Tn. We subtract T sub L from both sides. And we find out that Tn equals 13 minus TL. I think I may run out of space here, but we'll see what happens. So this equation becomes 4,200 equals RL plus 100 times this 13 minus TL. Okay, and so these are the two equations we're kind of looking at here. We need to do some simplifying, so we need to FOIL this out. So 13RL minus RLTL plus 1,300 minus 100 TL. Okay, so let's keep simplifying here. Notice we can subtract 1,300. We get 2,900 equals 13RL minus RLTL. That's gone. Minus 100 TL. Okay, this is where this first equation comes back into play because RLTL equals 4,200. So we can substitute again. 2,900 equals 13RL minus the 4,200 from above minus 100 TL. So if we add that 4,200 to both sides, that's going to give us a 100 and 67. Okay. We've still got two variables here. And what else do we need here? Oh, I see. If we go back to this original equation, notice we've got an RL and a TL. We have to relate them to each other. So if we look at this one, back here, I'm circling it again, we need to solve for one of those. So let's just go ahead, and it doesn't really matter. Let's solve for, we'll just divide both sides by TL. That'll get the RL by itself. So I'm going to have to erase this, I'm sorry, so that we have some more space to write. Get everything? There we go. So from here, we're coming back over here. We've got 7,100 equals, we're replacing the RL with 4,200 over TL, and then we've got minus 100 TL. So this is one of these rational equations. To get rid of this fraction, we multiply everything by TL, every term. So we're going to get 7,100 TL equals, this cancels with this, oh, I've got to multiply that, and I don't have a calculator. So, all right, old-fashioned way, 13 times 42. $546, so 546 minus 100 TL squared. Okay, so now notice it took us that long to get the quadratic. Now that it's a quadratic, we bring everything over to one side. So I'm going to move everything over here. 100 TL squared plus 7,100 TL minus 54600 equals 0. Now notice everything's divisible by 100, so we can get rid of these zeros when we divide by 100. And we need factors of negative 460, negative 546. That will add up to be 71. So TL, TL. Notice again, different signs, positive, negative, and of course I'm out of space again. Let's erase my chicken scratch up here. And let's find some factors of 546. Well, let's see. 6 will go in there. Let's try that. 546 would be 6 and 91. Okay, that's relatively close. That gives us a difference of, if this one was negative, that gives us a difference of 85. So let's see. How about 8? Does 8 go in there? Let's try 8. Again, with a calculator, this is easy. For me to try and do it in my head is a little bit more difficult. So 48 would be 66. That's not going to work. So 8 won't work. Let's try 9. 9 will work. I believe, no, it won't. So we're not going to try 9. Does 7 work? 49 and 56. Yeah, 7 will work. Let's try 7. Oh, sorry. So negative 7, and 7 goes into 54 7 times. It would be 49, and it goes into 56 8 times. And that is the one that works. So minus 7 plus 78 equals 0. Again, with the calculator, that's going to be a lot easier. So we find out when we set these equal to 0, TL could equal negative 78, or add 7, TL could equal 7. Well, obviously, again, in real life, that doesn't make sense. And so we get TL equals 7. Oh, I switched the screen on this here. Hang on. Get back to, there we go. So TL equals 7. So if the time to Los Angeles was 7 and the distance was 4,200 kilometers, we take 4,200 divided by 7 to find the speed, and we find out that it was 600 kilometers as we traveled to Los Angeles, and that's what the question was asking. So long process there. That one took some work. But if you'll take it one step at a time, that's the way that's going to help us out. Okay, this one's a long one, and I split it up on several slides. So it says an object is thrown or fired straight up at an initial speed of v sub 0, reaches a height of h after t seconds. So velocity, height, time. And the formula is given to us right here. This is the key piece of information other than just identifying the variables. So suppose that a bullet is shot straight upward with an initial speed or velocity of 800 feet per second. So that's our v sub 0. When does the bullet fall back to the ground? Okay, so going to the next slide, I've saved the important information there. And so we've got our formula still. And we know that h equals negative 16t squared plus 800t. We want to know, when does the bullet fall back to the ground? Well, what is the height when the bullet is on the ground? 0. So we just solve this. Notice these are both divisible by 16. So we're just going to divide everything by negative 16. So t squared minus 50t. We can factor that, factor out a t. And we find out that t equals 0 and t equals 50. Well, t equals 0 is when they fired it. T equals 50 is when it is going to fall back to the ground. So 50 would be 50 seconds is going to be our answer for that first part. Next, suppose that a bullet, and it's still shot up, when does it reach a height of 6,400 feet? So our height is now 6,400, negative 16t squared plus 800t. Again, this is quadratic. We want to move the 6,400 over. But again, everything's divisible by negative 16, so we're going to get t squared minus 50t plus 400. So we factor this, get t and t. The signs are the same and both negative, so negative and negative. And factors of 400, well, they've got to add up to be a negative 50, so we could try 40 and 10. We could just list them, but we can see that negative 40 and negative 10 is probably a pretty easy one, and it works. So when we set these equal to 0, each one, this will give us t equals 40 when we add 40 to both sides. This will give us t equals 10. So notice that it actually crosses that amount, 6,400. It actually goes there twice. When t is 10, it's at that height, and when t is 40. So in other words, think about it. It's going up and coming back down. This is when t is 10. This is when t is 40, those two spots. So it's going to hit that elevation twice. Okay, and now when does it reach a height of 2 miles? Oh, 2 miles. Height, 5,280 feet is 1 mile, so multiply that by 2, and we get, this is easier when I have you guys doing this on a calculator for me. So 10,560 is our height. We move it over. We divide everything by negative 16. Oops, I forgot my t there. That'll be plus, and 16. 96 goes in there. 6. 96 again, so 660. So again, we're going to try and factor this. Signs are the same, both negative, same, both negative. Always check those signs. Well, we know 66 times 10, but that's too big. That's 76. We know 33 times 20, so it's got to be somewhere in between there. Oh no, that's still 53. That's still too big. 30 times 22, that's still too big. So what happens here is we find out that this cannot be factored after we write down the factors. And so what we're going to do is go quadratic formula. So t equals negative b, that would be 50, plus or minus the square root of 50 squared is 2500 minus 4 times a times c over 2 times a. And as we look at this, inside the radical here, we've got 2,500 minus, I'm going to cheat and use a calculator here. It's not really cheating. I would prefer you guys do use a calculator to do a problem like this. 2640. What that tells us, that's negative 140. So negative 140 is inside the radical. Remember the discriminant idea? There's no real solution to this. In other words, the, what is it, a bullet? The bullet never reaches a height of 2 miles. So there's no real answer for that. It never gets there. So that one, the answer is never. The last part of our example is how high is the highest point that the bullet ever reaches? In other words, what is the vertex of this parabola? We know this is a parabola. The equation here, again, is so how do we find its highest point? Remember that the highest point of a parabola is always that little equation. We use x most of the time, but in this case the variable is t, so I got to switch that. So t equals negative b over 2a. So negative b would be negative 800 over 2 times negative 16. And just doing some reducing here, we know that this cancels to a 1 and this cancels to a 50. And then 50 over 2 is 25. So when t is 25, that will give us our maximum height. And so we can just plug that in. H equals negative 16 times 25 squared plus 800 times 25. And again, I am going to use a calculator for this because I don't want to have to try and do that in my head. So 16 times 25 times 25 gives us negative 10,000 for this first part, plus 800 times 25 gives us 20,000. All right, and when we add that up, we get 10,000. So 10,000 feet is the highest it's ever going to get to, and that explains why it never reached 2 miles, which was over 10,000 feet. But that's our answer to part D. Problems to take a look at. And some of them do have multiple parts, but as you look at that, you're going to have some time to work on those, again, in class, and I think you're going to have a weekend here. So those are the problems to look at for section 1.3. It is on page 105 to 107, so take a look at those, please.